Hey everyone, today we're going to focus on one of the simplest yet most powerful algorithms, linear regression. Linear regression is a supervised learning algorithm used to predict a continuous target variable based on one or more input features. Basically, the idea is to find the best fitting straight line through the data points that minimizes the difference between the actual and predicted values. In a simple linear regression, we have one independent variable, x, and one dependent variable, y. The relationship between them is described by the equation y equals mx plus b, where m is the slope and b the intercept. The goal is to find the values of m and b that minimize the cost function. This can usually be measured with the mean squared error, or MSE for short. Now let's jump into coding a linear regression model. We'll be using Jupyter notebooks for this demonstration. But first, let's add some libraries to the mix. We have standard libraries like NumPy, pandas for the data frame, matplotlib to show the graph, and from sklearn we have the linear regression and the mean squared error that we've seen before. Now we run it, add some arrays. Now run it, and if we check the array, we see that it has this structure, and it can't be this structure to pass to the linear regression. So what we're going to do is reshape the array, passing -1, 1, copy it to the one here. So we run it, and if we run it again, then it has the right structure, one-dimensional array to pass to the linear regression. Now we just need to add this to a data frame. So we do data frame pd dot data frame and we passed an x value that will be x, and an y value that will be y. Now we can't do it like this. We need to flatten the arrays, so we do dot flatten. This will remove all these sub arrays, making it just one array. And we do the same for y. Now I can show you the difference between a flattened array and a normal array. So if I run this, you can see that it doesn't have the arrays in them. So we run it. And now we can visualize it. So let's add a scatter plot where the x will be the x column of our newly created data frame, and the y value will be our y column. Let's add some labels. Let's say x label will be x, and the y label will be, can you guess it, y. And to show it, we just simply put show, and if we run it, we can see our values mapped in the graph. And now for what you're here, we're going to create a model that will be of type linear regression, and that model will fit the x and the y arrays. To draw the regression line on the graph, you only need to calculate 2 points, the lowest and the largest, and then we connect those 2 points with a line. Let's start with the x value. So if we do np.array, and the first point will be the lowest, so x.min. The second one will be the largest, so we do x.max to find the lowest and largest points. To predict the y values of these 2 points, we'll create predict, and we'll call the model dot predict, and we pass the newly created X-ray. Now, if we go to the graph edit above, do the same thing, but this time we plot a line with the newly created X-ray and the Y predict, and add a color to it to stand out. So let's say color red, and increase the line width. Let's say 2. And we run it. We can see the regression line here. So we have our regression line, but let's make things a little bit more professional. Let's add a new column here, a new import, the train test split. This will split the data into training data and test data. So let's add 4 new variables, the X train, the X test, the Y train, and the Y test. This will be equal to this, and it will receive the X arrays and the Y arrays. Let's also add the training size. We'll do like 70%, so 0.7, and the test size will be like the remaining 30%, so 0.3%. 3. We'll also add a random state. Let's put a random number like 12. This random state will make sure that if we run this comment and this data again, we'll have the same result, so that we don't have like random data every time. This is very, very crucial to train. Let's add the X train to our fitting model and the Y train here to the model. If we run this and run this again, now that we fitted the model, we can calculate the intercept and the slope. Let's start with the slope. So let's print something like slope is, then we do model dot coef underscore, don't forget underscore, and it's the first element. And for the intercept, we'll do the same thing, intercept, and it's the model dot intercept with the underscore at the end. If we run this, we have the slope and the intercept values. Now for the prediction, we don't need this X array, and for the Y predict, it's the same thing, except instead of the new array, we have the X test. Basically, we trained the model with the training data, and now we're going to test the model with the testing data. And if we run this, let's also evaluate the model with the mean squared error. So if we mean squared error equals to the library we imported, mean squared error, it will take the Y test, basically testing values, and the predict values, Y predict. Let's print it. So we say something like mean squared error will be MSE. Let's run it. Mean squared error 38.78. Now let's also change the graph. We'll be using the X test for both the scatter and the plot, and we'll compare the Y test with the Y prediction. So do this, and we predict, Notice that we have fewer points because we are only seeing 30% of the data. 70% was used to test the data. And yeah, I think it did an okay job. And there you have it. We have successfully implemented a simple linear regression model in Python. We covered how to implement a model, how to evaluate the model with a mean squared error, to show the model with the graph, and to split the data into training and testing data. Hope you learned something from this tutorial. See you next time.